Hey, welcome to The Explainer. Today, we're going to break down a really powerful but also very specific tool in the VMware world, raw device mapping, or as you'll hear it called, RDM. Think of it like a special backstage pass for your virtual machines, letting them get direct access to your physical storage. So, let's start with a situation you might have run into. You've got your applications humming along nicely in their virtual world, which is awesome for flexibility. But what happens when one of them needs to, whisper directly to the physical storage hardware? Maybe to use some special feature on the SAN or to get every last drop of performance. And that right there, that's the classic virtualization dilemma. This whole concept of abstraction is fantastic. It gives us so much power, but it's not a silver bullet. It has its limits. So, usually, that software layer, that hypervisor, it's your best friend, right? It hides all the messy hardware details, lets you move VMs around like they're just files, and manage everything from a single pane of glass. But sometimes, that helpful layer can actually get in the way. It can become a barrier, blocking that direct line of communication we were just talking about. Okay, so how do we punch a hole through that barrier when we absolutely have to? Well, this is where VMware comes in with a really clever solution to this exact problem. At its core, RDM is exactly that. It's that special pass we mentioned. It creates a kind of shortcut, a proxy, that points a virtual machine straight to a raw storage device, a LUN on your SAN. It kind of sidesteps the normal VMFS file system to create this much more direct connection. Okay, but how does this actually work? The way this direct line gets set up is, well, it's pretty slick. It's not just a switch you flip, it's a really elegant bit of engineering. It boils down to this really simple, but honestly brilliant three-step dance. Instead of a big ol' virtual disk file, RDM uses this tiny little mapping file that lives on your data store. And when the VM wants to talk to its storage, this file jumps in, acts like a proxy, and just redirects the request straight to the physical LUN. And this is the whole point. This is the magic right here. Because of that direct link, the operating system inside your VM can now shoot SCSI commands directly to the storage array. Basically, your VM gets to pretend it's a physical server with its own dedicated disk, unlocking all sorts of hardware-level conversations. Okay, but it's not quite that simple. This direct pass isn't a one-size-fits-all kind of deal. When you go to set one up, you've got a really important choice to make between two different ways it can operate. And this choice? It's a classic trade-off, really. It boils down to asking yourself, how much of that virtualization goodness are you willing to give up for that raw, direct hardware access? This whole decision is wrapped up in RDM's two modes, virtual and physical. So this table here, it lays it all out pretty clearly. On one hand, you've got virtual mode. It tries to be the best of both worlds. It gives you direct LUN access, but still lets you use key VMware features like snapshots. Then you've got physical mode. This one goes all in. It does the absolute minimum virtualization, passing almost everything straight to the hardware. That makes it totally compatible with your SAN tools, but there's a catch. And here is the absolute most critical takeaway. I mean, if you remember one thing, remember this. If you choose physical mode to get that deep hardware access, you completely lose the ability to take those normal VM snapshots inside vSphere. Gone. The SAN is in charge now, so you'd have to use array-based snapshots if you have them. So with that big trade-off in mind, especially that snapshot thing, you can probably guess that RDM isn't something you'd use every day. So when is it the right tool for the job? Where does it really shine? Yeah, it's really for these super specific niche scenarios. Think of things like Microsoft failover clusters, where you've got multiple VMs that all need to see and scribble on the same disk at the same time. Or maybe those I/O-hungry databases where every single microsecond of latency matters. It's also perfect for any application that needs to use hardware-level tricks, like SAN replication, or even some old-school legacy app that just refuses to work without talking SCSI directly. Okay, so before you get all excited and start setting up RDMs everywhere, let's talk about the fine print. There are a few, let's call them rules of the road, you really need to know to stay out of trouble. And these aren't just suggestions, they're pretty much non-negotiable. First up, you map the entire LUN, no slicing and dicing. Second, if you want something like vMotion to work, every single host in your cluster has to see that LUN with the exact same ID. Consistency is everything. And just to hammer it home one last time, say it with me now. Physical mode means no VM snapshots. Seriously. So at the end of the day, RDM is a super powerful, super specific tool for solving some very specific problems. It's this amazing bridge between the virtual world and the physical one. But it does leave us with a really interesting question to chew on. In a world that's moving so fast towards hyperconvergence, things like vSAN and cloud storage, what's the future for a tool that's so tightly connected to traditional physical hardware? It's definitely something to think about.